today's video, we're going to be solving a full-length past paper question of binomial. So this would give you an idea of the kind of questions you should expect in the past papers and how exactly you're supposed to answer them. Now, do remember all the formulas that we have learned. Yes, they're very useful. Okay, we're going to be using them pretty much all the time. But having said that, there will come a point where all the formulas that we have learned are not going to help you as much as you might think, because there will come a question where it will just boil down to your common sense and your understanding of the whole idea of expanding binomials and then multiplying, and what terms you need to multiply in order to get maybe the coefficient of x, maybe the coefficient of x squared. So you got to keep your eyes open for that also. Okay, don't just rely too much on the formulas. Yes, they're important, but at the same time, keep your eyes and ears open whenever you're attempting a question. Okay, so in this question, you'll know exactly what I'm talking about. Okay, so question number 3 part A says, find the first three terms in the expansion of 4 minus x upon 16, the whole thing to the power 6 in ascending powers of x. Give each term in its simplest form. Okay, so let's get to work. So we have to find the first three terms. That means r is going to be 0, 1, and 2. Okay. So 6c0, that's going to give us the first term, 4 raised to the power 6 minus 0, so that's 6, and minus x upon 16 raised to the power of 0, so that's the first term. Then the second term can be obtained by 6c1, 4 raised to the power of 5, minus x upon 16 raised to the power of 1. And then finally the third term, for which we'll do 6c2, 4 raised to the power of 4, minus x upon 16 raised to the power of 2. Okay. Now 6c0 we know is going to be 1, 4 raised to the power 6, well, you can't work. I mean, I can't work that out mentally. I don't know about you, but 4 to the power 6 is 4096, so that's 4096. 6c1, so 6c1 is 6 into 4 raised to the power of 5. So we're looking at 6144. So basically 6 into, let's write this out one by one, into 4 raised to the power 5, so into 1024 into minus x upon 16. So we'll simplify this now. So 6 into 1024 divided by 16. So we're looking at minus 384x. It's a good idea to do it step by step rather than just doing it directly. Okay, that would be my recommendation. 6c2 is going to be 15. 4 raised to the power 4 is going to be 256. So that's 256 into x squared over 16 squared, which, if I'm not wrong, is 256. Yep, 256 it is. Okay, so luckily for us, 256 and 256 get cancelled out, and now we're looking at 15x squared. So we're going to give our answer nicely now. So 4096 minus 384x plus 15x squared is the final answer to part A. Okay, so we have the first three terms. There you go. Okay, then we come to part B, where it says hence. So what does the term, I mean, why exactly has the question used the word hence? Because this has to be linked with the solution to part A. Find the term independent, you can see that I've highlighted the word independent, of x in the expansion of 4 minus x to the power 16, which we expanded earlier, into x minus 1 upon x, the whole thing squared. Okay, so let's not worry about 4 minus x upon 16, the whole thing to the power 6. I mean, let's not worry about this. Okay, and let's take this into consideration for now. Let's worry about this. So this is technically a minus b, the whole thing squared. So if I want, I can use the binomial expansion formula to expand this, but you don't, I mean, that'd just be wasting a lot of time. Because it's whole squared, we know an identity for this, so I'm just going to use that instead. So x minus 1 upon x, the whole thing squared, the expansion of x minus 1 upon x, the whole thing squared, would be x squared plus, sorry, not plus, minus 2 into a, which is x, into b, which is 1 upon x, plus 1 upon x whole squared. So let's work this out. So we have x squared, the x and x get cancelled out, minus 2, that's all we have, plus 1 upon x squared. So this tells us something, this kind of tells us what we have to do in the next couple of steps. Okay, so we have the expansion of 4 minus x upon 16 to the power 6. Okay, I'm not going to write it down right now, we'll just let it be as it is. But now we also have the expansion of 1 x minus 1 upon x whole squared, which is basically x squared minus 2 plus 1 upon x squared. Okay, and towards the end we want the term that is independent of x. Okay, so towards the end we want the term that is independent of x. Okay, so what exactly are the terms that we need to multiply so that towards the end we get the term that is independent of x? Okay, so that means x should just cancel out. Okay, there should be no x. Okay, so let's see. Let's go back. We have the expansion over here. And now over here we have x square. Okay, so we have this x square over here. So what term should I multiply x square with so that the term that I end up with is basically independent of x? Now if you think about it, x square is in the numerator, and in the expansion above, all the terms will have x regardless of whether it's x bar 1, x bar 2, x bar 3, all of them will have x in the numerator, x to raised to some power in the numerator. So that means no matter what you do, if you have x in raised to some power in the numerator, and if that is being multiplied by x squared, towards the end, there's no way you could be left with a term that's independent of x. So that means we're not going to worry about multiplying x squared with anything at all. Okay. Now minus 2 is a constant. Okay. So that means what I'm looking for over here is some constant that I can multiply minus 2 with, so that towards the end we get a term that's independent of x. And we do have a constant in the expansion of 4 minus x upon 16, whole thing to the power of 6. And the same thing applies to 1 upon x squared. Now 1 upon x squared has x squared in the denominator. So that means if I can multiply 1 upon x squared with a term that has x squared in the numerator, okay, so that way, let's just write a plus sign, okay. We're not sure whether it's going to be plus or minus. In fact, it is going to be plus, yeah. So yeah. So once that is multiplied with a term that has x squared in the numerator, towards the end we will have a term that's independent of x. Okay, now let's use the actual terms and see how this works. So in the expansion we got 4096 minus 384x plus what was it, 15x squared, x plus 15x squared. Okay, and this we're multiplying, remember, with x squared minus 2 plus 1 upon x squared. And what we want towards the end is the term that's independent of x. So as far as 4096 goes, 4096 will be multiplied by a constant, okay, so that we have the term that's independent of x. So 4096 times 2 gives us 8192 negative 8192. And then let's switch to another color. Minus 384 sadly cannot be multiplied by any such term, so that we can have a term that's independent of x. 15x squared, there's no point in multiplying 15x squared with x squared because that's not gonna give us a term independent of x. And there's no point in multiplying 15x squared with minus 2. Again, we'll have x squared towards the end. However, 15x squared multiplied by 1 upon x squared will just cancel out the x squares and we'll just be left with 15. So that means plus 15 is another term that is independent of x. Now let's sum them up. So we have minus 8192 plus 15. So we are looking at minus 8177, and that's our final answer, meaning that's the term that is independent of x in the expansion of what's given. So yeah, with questions like these, you have to keep your eyes and ears open, and you have to sort of manually check that what are the terms that you can and should multiply, so that you can get, at the end, you can get whatever is asked from you. So yeah, that's the end of this video. This, I should mention, is a question from June 2020, paper 1 variant 2, and I hope you guys have understood it. And see you guys in the next video with another past paper question. So until then, take care. Bye-bye.